the first time I've actually gotten to meet him, because we come from opposite sides of the communication world. He's here to tell you about the scary things like ICE and stun that really confuse a lot of people. So he's going to make it easier and clearer for you.
Thank you very much. Hi guys, thank you for sitting in on my talk, especially when Varun from CoolStats is giving an interesting one on AI and WebRTC. So, and if you're here because you couldn't be bothered to stand up and walk out, I understand, that's fine. So I've been CTO of Xirsys since 2013 when it was officially created. We set up Xirsys after attending Google's first conference in San Francisco about WebRTC. It was exactly what we had already been doing in many ways, just took it to the next level. So we thought, you know, it's what we should be doing. It's what we should do. The sister company, Fluxys, has been around since 2002, providing RTC and streaming video capabilities, mostly through Flash. They were providing not just services, but bespoke services and implementations as well. Fluxys was the only company outside of Adobe that had a license to provide P2P in Flash as a third-party provider, and also Influxys had acquired Adobe's lifecycle collaboration services, which they renamed to Influxys Collaboration Services. So, you know, they have a long history of working with RTC and video and everything else real time. Now, way back, you know, in the noughties, being in the Flash community, there's quite a notable difference between how it was then and how we perceive things now with more sort of JavaScript developers and people doing things with video now and RTC. Back then, there was, you know, the community was the best part about Flash. There were some real sort of superstars creating some really impressive pieces of work, sometimes just because they could. It was mostly creative developers, you know, experimenting and just seeing what was possible and just making things happen. And I think a lot of that was because the entry for creative developers was a lot, you know, much more shallow curve. And a lot of the technologies behind it were built specifically for Flash, so they work well together. Whereas now, there's a bit more of a divide. So we get a lot of support tickets that show that there are, you know, talented developers, people that have real amazing skills in building front-end applications and server applications. They kind of don't want to cross over and learn too much about how, you know, the whole video and audio aspect, the whole streaming side of it actually works. They kind of draw a line, and we see that in the questions that we get. So it's what I like to refer to as, you know, it's like the human condition, you know, where if it's something that people are comfortable with and like, they will lean towards it. But in exactly the same way, they will lean against the thing that they don't like, that they feel, you know, adverse to. So this is like, you know, when I think about that, I think about my son, who, if I give him a chocolate bar, there's a pretty good chance he's going to eat it. But if I put a plate of liver and onions in front of him, either he's going to say no without even trying it, or he'll put a mouthful or a chunk in his mouth and he'll chew it 100 times before trying to swallow. It's not something he would relish eating. So, and I think, you know, we're all like that. If something doesn't appeal to us, or it seems like a steep curve to overcome and learn, then we'll avoid it for as long as possible. We'll procrastinate, and we'll do the things that we actually enjoy doing and want to do. And so because of that, we have a lot of intelligent people asking dumb questions, dumb problems. So, you know, it's a case of the simple issues are always the hard ones to debug, aren't they? I mean, if you've got a big glaring issue, you usually know how to fix it. But the simple issue, you know, might not even really know what it is, and it's not until you find it and you curse yourself for not thinking of it sooner. And that's obviously much more prominent when it's in an area of your development that you really don't understand. So if you have, you know, if you know JavaScript, for instance, and you understand the API and you build an application that generally looks, you know, wonderful, but you don't understand what happens beyond that, and there's a problem somewhere beyond that, then you're sort of stumped. Now, I like to read questions on Quora, and one question I came across was that there. Someone said, what's the answer? How is that possible? And there were a number of maths teachers and mathematicians, and either saying that's not possible, or someone's they've thrown you a trick question. One guy said, yeah, actually there is a really complex way of looking at this, and you can come up with the solution by following this, that, and everything else. And I just thought, when looking at it, if I gave this to any number of developers, they'll answer it immediately. And they're not mathematicians, but it's a problem that that we deal with. So I mean, if I just put that there, then I'm sure that's what most people would think about as developers, because we often deal with infinity as an issue, especially if you're a JavaScript developer. It becomes a known problem. So it's often the idea that if you see things in a certain way, if you have a narrow view of something, then you're missing ideas outside of the box that you're not training yourself to look for. You're not standing far enough back and giving it enough of an alternative thinking in order to solve the problem. Now, as I say, I do handle support tickets in Xirsys quite regularly. I'm not the first person that support tickets will come to, but if someone else doesn't want to answer it because it's not a question they're comfortable with, or they don't know how to answer it, etc., then it will eventually land up in my lap. And a lot of these tickets have a theme. A common one we'll get is asking for server logs. So a company will say, well, this works fine when we've tried it in the past, but we're trying to make it work at the minute, and we can't make it work. Is it possible we can get access to your turn server logs? And I'll have to write back and say, we don't really keep logs on that. We keep very few logs of our turn servers. We log when people connect. So, we could find that information. We log how much traffic goes through a particular connection. But that's really about it, because there is not a huge amount you can get. And beyond analytics, trying to work out how quick the packages pass through, or how many packages you're getting, etc. And it's not really useful to the end user. And the reason why we don't present any logs to users of our service is because this is all information that they can get themselves. So now, I believe, I'm not 100% certain, but I think that because a lot of these developers don't understand really how a turn server works, they kind of perceive that it must be like, old school server development. When you have an intelligent server that has a lot in it, the client is very thin, and it's the server that's doing all the work. When, as a lot of us know, with WebRTC, it's not that way. It's actually the opposite, because all the information, all of the capabilities are in the browser. Because what we ultimately want is for there to be no server at all. And then you have an all-you-can-eat situation. The food is free, and you're in an ideal situation. But when something goes wrong with the connection, a lot of these developers forget that. They know that this technology should work peer-to-peer, but they forget that the buck generally stops with their own environment, their own software, their own network. And that the turn server is doing very little, because the turn server ultimately is dumb. It doesn't know much of anything. When people were developing applications with Flash Media Server and what have you, the server did quite a lot more, because, as I said, it was designed for Flash specifically. A turn server isn't designed specifically for WebRTC. It's designed to be generic for all kinds of media-related applications. So it does just enough to be useful. Now, as you might know, the underlying protocol of turn is the stun. So I always think of stun as being like, in the old days before mobile phones, if you moved house and you'd called BT beforehand to install a landline telephone, and you hadn't received any letters to tell you what your new phone number was going to be, so the first thing you'd do is you'd pick up your phone and you'd call your mother and say, when I get off the phone, dial 1471, write down my phone number, then call me back and let me know what it is. So then you can give it to everyone else. And Stun's a lot like that. So it's just an echo server. You reach out to, to the server. It sends a packet out. The Stun server then copies your IP from the header, pops it into the body, and sends it back. And that's all it does. And that is the one thing we always need for a WebRTC connection. For most of the connections that get established, you don't need Turn, you just need this one simple service. And obviously it's because your local machine doesn't know its public IP, it only knows its local network IP. Turn is built on top of that, which provides extended capabilities, but it's just a messenger. It's just the guy that takes packets from one person and passes them to another, and vice versa. So, it's like a guy on a bike delivering newspapers or messages or what have you. It does have additional capabilities in terms of being more flexible. So it will have multiple transport types. You've got TLS and UDP and, TCP and DTLS. I said that probably in a random order. So, but that's for the client only. The client being the person that controls the session, the person that establishes the session. The other person is the peer. Peer currently in WebRTC can only connect via UDP, UDP port. So that creates its own issues. After that, the notion of allocations, which is a session. And all an allocation is it's two main things. One is a lifetime, to say a session should be opened, but it will time out unless you keep it open. And the other is the port on the server that the peer will connect to. And it's just those two things, and that's it. We also have permissions. So permissions, if you imagine the allocation being the port on the server, the permission is to say only these people can connect to this port on the server. So a permission is just an IP and port pair. Now, a Turn server can actually support multiple permissions per allocation, but WebRTC out the box just supports one permission per allocation. So it's, again, very, very simple. Just that little bit of information to say, I will allow information to be sent to and from this peer. We also have channels. Now, a channel is like a high-speed packet. So once you've established a connection, and I've missed a slide out here on authentication, which again is very simple. It's just a hash of a user's username, the Turn server's realm, and their password, and then it's compared with what's sent in the packets from the client. But once all that's established and everything's working nicely, everything's set up, then the WebRTC client itself can choose to do what we call a channel bind, where it says, I'd like to send packets a little bit quicker. So let's use I think it's 4 bytes of a header instead of the chunky bytes that a standard Turn packet will use. And so you can fit fit a larger body, which either means reduced bandwidth or it means more data, higher quality video. So that's an option. Now, in WebRTC currently, and has been always, as I'm pretty sure it's still the same, you cannot force a channel bind. It's up to the browser to work all that out. So, if it happens, then fantastic. And then finally, we get the refresh, which is just like a ping. So the client will say, I want to keep this allocation alive. If it doesn't, the allocation will disappear, but the refresh is what keeps it open. None of the other messages, just a refresh. A refresh is typically 600 seconds. It can be otherwise, but it's about that. And you'll get a refresh occurring way more often than that. Now all of that kind of constitutes the entirety of Turn. You can add stuff to it, but that's the basic outline of Turn. Now, as far as I can think of, every socket server you ever build has all these things in some form. You want your to open ports for whoever you want to connect and receive packets from yourself. You want to ensure that you're refreshing the connection. You want to what else? Authenticate, obviously. You don't want anyone connecting willy-nilly. So there's nothing here that is any different to any other server. So when people talk about Turn servers and everyone thinks, oh, it's some mystical voodoo or something, it's not. It's just a simple socket server. What is different is that most people's socket servers will be far more complicated than this. They'll have functionality and APIs and things that take it, make it unique, make it specific to the use case they have, whereas a turn server is trying to be everyone's best friend, trying to solve a problem that everyone has. So once people realize this, then hopefully, the silly questions will go. So again, with the whole server logs, we don't have any. You can get this yourself. So if you understand the technology, you understand it's just a socket server, it's just TCP and UDP, you can figure it out. And other questions we get a lot of, and this may be appended to this one or any other of the questions, is look at my code, and it's this an absolute nightmare for me. This usually follows a question of, a statement of, we're not currently using your software services. We plan to in the future. My software isn't working. Can you have a look? And they'll offer their SSH information. And I have to admit, and it's horrible, I know it's going to be on YouTube and so I'm probably going to be inundated with these now, that more often than not, I do actually go onto the server and try and fix it. But as you know, if you're in an environment where you're working with software with other people and you're looking at your colleagues' code, it's often a nightmare, it's often ghastly, and you don't want to touch it. So when you've got someone you don't know working on a project you've never seen before, they don't really know what the problem is, and you're asked to look at it, and they're not even a customer, then it's one of those where you kind of have to be, probably should be a bit stronger and tell them, no, it's not going to happen, but I can put you in touch with someone who will, for a fee. So that I get that a lot. Another common question or statement we get is, it works fine on our local network. Now this typically means that someone hasn't, they're not using a turn server tool. It could mean that they've not configured the turn server on their application properly. We get this a lot with people who use existing libraries, simple WebRTC, for instance, because if you don't pass in the ICE connection string into simple WebRTC before it's initialized, then it won't use the turn service. And so there's varying reasons why it can happen, but it's always because in the public internet, it's not hitting the turn server. The reason why it works locally on a local network is because the connection setup bounces off your local NAT, so it never actually reaches a turn server anyway. It doesn't need to. You connect for what's called a host candidate pair, and it just works. Now, I have been on, it's not guaranteed when you're testing something on a local network that it will always work. I have been on networks where I've actually required a turn server to connect between two tabs on the same browser on one machine. But it's rare, and I have no idea why that was, but sometimes things don't work as you expect them to. Another one we get often is the connection works generally, but the video is blank. And this could be a number of problems. If you're getting audio in a call and you're not getting video, then you can pretty much discount that it being a turn problem, because the turn doesn't differentiate between the data that's coming through its ports. So if you're getting audio, then it's working. Everything's set up and everything's established, and you've succeeded. The reason why the video could be blank, very often, it might be because you've attached a stream from the video before you get a complete or connected state on the on-ice connection state change event. So you need to listen to that first before you try and attach the stream to your video tag, or you can experience this. Skip that one. Works on desktop, doesn't work on mobile. Now, this is a frustrating one. This could be a huge number of things, but again, with any of these issues, you need to think outside the box. So one thing I often suggest with this, mobile's a pain in the rear, because it's you can't run Wireshark on these devices. It's hard to debug what's going on in a browser on them, and you can use on iOS, for instance, you can hook it up and use Xcode to debug, but it's not easy. Usually the first thing you need to do is to roll out various possibilities. And to do that, you've got to ask a number of questions. For instance, does it work fine when you're using Wi-Fi? Or is it just 3G or 4G that it's a problem? If that's the case, it could be a timing issue. I mean, Wi-Fi generally allows things to connect a lot more quickly, and so race condition might only show up when you're using 3G. If it doesn't work on either, then maybe it's the browser. If it's fine on your desktop, but it's not fine in iOS Safari, then it could just be the API in Safari. So you kind of need to then abstract it from the mobile, perhaps get a mobile Wi-Fi dongle that supports 3G and 4G. I've got one where I can force it to 3G if I want to, or use both. And then you can debug that then with a mobile connection on a desktop machine. And it gives you, if you keep cutting off things that it can't be, then eventually you'll end up with the thing that it must be, and you can then fix it. Worst case scenario is it's your mobile network tariff. Some mobile network tariffs, I know they appear like they're symmetric nets, which is where the turn server expects a connection from a given IP and port, but when it eventually does connect, it's from another IP and port. And there are ways to test for that as well, which I can explain in a minute. Another question is it connects fine, but stops working after 5 minutes or so. Now this, the browser does a lot of the tasks with communicating with the turn server automatically. So it's unlikely to be anything like refresh messages not getting through. They're sent quite constantly, quite frequently. Every time I've come across this and we've eventually figured out the issue, it's been because there's some other asynchronous task running in the browser that kind of messes everything up. It's that I've experienced. It's never been an actual issue with the network, or networks can be dodgy, but usually you knew that already. So have a look. Try stripping down your application. Remove things that you don't need for the actual connection, and just run that. Alternatively, try a different application. Other applications use WebRTC. If you can try one of those, and the issue still happens, then it's probably network-based. If it doesn't, then it can't be network-based. So, there are things you can do. And the most annoying question or statement is it works with someone else's service. Now, we have about, I don't know, a couple of thousand turn sessions in use at any 1 minute throughout the day. So we know people are using our services. And so when someone says, it doesn't work, your system must be a load of rubbish, because I know my code is perfect. So this feels a little bit insulting. And usually the problem with this is simple configuration. Our iString endpoint produces data in a different way to other third-party turn server companies. And so it's just attention to detail. What object am I passing into my application, and how am I dealing with it, compared to how I was dealing with it with some other platform. And this works in both ways, and I'm sure these companies get exactly the same thing. They'll say, well, it worked with Xirsys, but it's not with yours. What's the problem? So I guess it's probably developers that they kind of throw in the towel early, and they're like, well, I haven't got the energy to figure this out. I can contact someone who should know better, and tell them it's their problem, and get myself out of trying to figure out something that I'm uncomfortable with. At least that's how it appears to me. So ultimately, solving problems, it's always using common sense. Try and look at the problem differently. Try and take yourself out of what you're doing, take some steps back, maybe go and have a coffee or what have you, and try and rule out possible scenarios. Reduce the problem to an absolute certainty. And then once you know where the problem lies specifically, then you can start targeting it. And it might be contacting us and saying, we've got this problem, we've narrowed it down to this. Can you help us? And we're then better able to help you with the problem versus questions like, take a look at my code, which kind of isn't really helpful to anyone. Now, some of the ways in which you can approach these problems, or the first way I always suggest people look at these problems is to try another application. We have a demo for this exact reason. We don't have a demo so that people can have free video chats with each other. We have it so that people who are using our service, when their app doesn't work in a specific network environment, they can pull up our demo, they can run it in the same environment with the same client, And if that works, then you know that it must be something in your app. If it behaves in exactly the same way, then potential causes then are network related. There's something going on either the peers network or your own network that is leading to this issue. So using an app is a very good way of finding that out. Now, if you're pretty sure it's not the networks, try someone else's app. So app RTC, if app RTC works perfectly well, our demo doesn't and your app doesn't, then we've screwed up. And we need to find out what the problem is. I like when people contact us and say, there's this edge case where it doesn't work, and it's specifically with your return servers, and we've done everything else, and we know it's yours. Because in the past, this is certainly in the early days, we've been able to iron those out and fix them, and then everyone benefits. So, we're not infallible. We do make mistakes, and there are so many issues that can occur in our sort of service that, we're going to get it wrong. And especially seeing as, although we've been in the RTC game and streaming video game for a long time, we're not telcos, we're still applications developers, and a lot of the talks that I've been in on this conference, just completely over my head, Some of them, I felt a bit smug and thought I knew something about, but there's a lot we don't know about, so getting feedback from our customers is good for us, it's useful. Some other tools that, did I need to go down? No, I did. Some other tools that help out. Test.webrtc.org I find very useful. It gives you a quick overview as to the capabilities of your WebRTC client. And the good thing is you can plug in other turn servers. So if you set up some static credentials in Xirsys, for instance, and then you run that, you compare it to other people's, it gives you immediately the differences in the video connectivity, IPv6 connectivity, all kinds of stuff that you can then compare and work out, is it my app? If they're both the same and you're still having issues, and again, it's a useful tool. The samples, WebRTC samples, there's a load of these, and this is a fantastic educational resource to be able to. And I'm telling people this all the time. When people don't understand what turn does, I always tell people to go away and read the RFC, and that usually kind of, people's face go white and they start to tremble at the knees because, the RFCs don't look very inviting. But the good thing about the RFCs is that they're very concise and they're very easy to understand. There's no ambiguity because they need, they define the particular technology. So it's sort of like the point of truth. And so if you read the turn specification, it gives you a huge amount of knowledge and power to be able to understand how that element of everything works. And then you can start reading about RTP if you want to, or even TCP and UDP is all up there. So those are good resources. But certainly these samples for understanding the API in a JavaScript that you use and how to implement it properly, that's a fantastic resource. So I would recommend that. Right, so next we have WebRTC Internals. Now, WebRTC Internals is a Chrome-specific thing. Firefox has DevTools Media Panel, and there is a WebRTC Externals, which is exactly the same code, repurposed as an extension, which I believe works in Chrome, which is, okay. It works in Firefox, it works in Edge. I think I put Safari. I think it works in Safari, but I'm not 100% sure. But it looks exactly the same. And again, WebRTC Internals is one of those things where you think, you're not really helping me. It's got a load of useful information, but when most developers look at it, they think, this means nothing to me. It looks atrocious, and so they hide away from it rather than using it, which is probably the single most powerful tool to figuring out your connectivity issues, or at least while you're building your app specifically, and then maintaining it. Figuring out where your app is doing well in terms of throughput and what have you on various networks. WebRTC Externals looks exactly the same. So you're not gaining anything in terms of readability or given kid gloves treatment with that, unfortunately. And there's some documentation on this. So Philip Hank and Sahi Levi, did I pronounce that right? Yes, thank you. They have compiled 3 articles which they call the missing documentation for RTC Internals, and I would recommend reading them. They don't go into any detail, but they kind of ease you into at least understanding how it can be useful. So I would recommend reading those. They're not long. And again, at least it gives you that extra power to figuring out how to get your app running, or even while developing your app. It's very useful. Now, a WebRTC Internals page, the documentation that I just spoke about, that it talks about how the WebRTC Internals used to look like, the legacy. It's since changed to match standards, and that actually gives less information, unfortunately. At least I believe it does. So if you look at the top is the iString. If you're using our service and you don't see Xirsys turn service in there, you've screwed up in the configuration. The right-hand side, number 3, there is the get stats information, which gives you, in the legacy, it will tell you whether you're using relay or if it's a stun connection. It will tell you whether you're using UDP or TCP. It will give you the number of packages sent and received and all kinds of useful information. In the current one, it doesn't give you information about the transport type or whether or not you're using relay or stun, unfortunately. The left-hand side is all of your API calls and the parameters passed to them, and also the event calls and the parameters for those as well. And that's really useful for going through your ICE candidates. Obviously, the other thing as well is I can show you this probably. So this is the legacy. Now, the candidate pair here that were used for a connection are highlighted in bold, so I can see immediately which one I'm using. There's the UDPs at the bottom. Just there. I know it's UDP, and I know where's somewhere else it will tell me, relay. So I know that was turn. If I look at the alternative, the more modern standards-based, I have no idea which one of all of those was the candidate pair in use. And when I open it, it's just a whole lot of information about packets. So legacy, I would recommend legacy while it's there. I don't know how long it'll be there, and I'm sure this will update, but in the meantime, legacy is probably a better friend for you. So certainly use that. And then obviously there's Wireshark, and Wireshark is wonderful. It's not so helpful if you don't have access to this on your client's network, because obviously you need a capture on both your network and your client's network. But essentially, you make a capture. I'm going to drag this over. You make a capture. You start the capture before you start your WebRTC connection, and you end it after your WebRTC connection. And you're probably going to get a whole load of stuff you don't want. But if you just go to the filter bar and type stun, press enter, then you get to see all of your packets, specifically stun related. And you can see the bindings there is stun calls to get your IP, and you can see where it's returned the mapped address, your IP. Then you've got your allocations, so it's requesting an allocation, but without credentials, so of course those fail, and then it requests again with the credentials, and those succeed. Then you've got the permissions. So it reads, you can actually see the processes that lead eventually to channel data being sent. Well, if you see that, then you know it's working. You know data's going backwards and forwards, and that's all you're really looking for. If there's any other problems, then it's in your app. It's not in the network connection. So that is, it's an absolute gem of a tool. So I would recommend using that, certainly. And something else that we've been working on, which I've been working to this, and is a turn server. So when I got involved in WebRTC in 2013, I didn't know what a turn server was. I figured, WebRTC, that's cool. And so to understand a turn server, I read the RFCs. That's why I can say go and read them yourselves. And I built myself a turn server in Erlang. And by building it and by actually seeing it work, I then felt like, I knew everything there was to know about turn. And it's not hard. There's not many moving parts to it, but it's a good exercise. And what I then did a couple of years later, I can find my mouse, is convert that to Elixir, because Elixir is a bit more user-friendly. It's becoming a very popular language and platform now. Well, it's still Erlang, excuse me, but it's syntactically it's nicer. And as you can see here, I've put each of the what I call the actions, allocations, authentication, channel binding, channel data throughput, creating a permission, etc. They're all simple modules. So this is all the pieces that make up an allocation. Nicely documented, very, very simple. It's not a big module at all, and they're all like that. So authentication is a nice small module. And so my hope is that by putting this out there, this is open source, it's under Apache 2 license, that if anyone actually wants to be able to not just understand how a turn server works, but also perhaps approach it with the idea that they can extend this in some way. You know, as I said, in the noughties and with Flash, we had all these creative developers, and they were doing some really cool stuff because they could. And I'm hoping that, you know, people will do the same with this. If anyone's taken a look at the CoTurn source, it's a fantastic turn server, but it's written in C++, and it's not for everyone, you know, to go and extend. It's quite complicated. You know, I've tried a couple of times and didn't succeed. But this is sort of an alternative where it doesn't have as many capabilities as CoTurn. It's built specifically for WebRTC. But it's far simpler. And so, you know, you could do a lot more with it. And as an example, I created a simple plugin, which I wanted to show today, but I couldn't get my Linux box connecting to this screen, so I can't show it, unfortunately. But the idea was that this here is a handler. So there's a couple of hooks in the turn server where messages get sent from the peer or the client. And the idea here was to set up a simple WebSocket. So this is a WebSocket handler here. It gets the data that's being sent from either peer or client. It formats it down here to JSON and then sends it to the browser. So you can run a session, both peer and client, and see both peers and clients' messages in chronological order listed down the page. And then you could just open any one you want to see the specific details of those packets. You know, which can be useful if, as I said, if you've got clients where you know you're not allowed to put Wireshark on their network, if it might be a financial organization or health or what have you, and it might have strict rules, then you know you could perhaps set it up so you can change the turn server they're using and then see the content that they should be seeing if they were able to use Wireshark, which is useful. But this is just an example, as I said. Hopefully people will look at this and say, you know, 2 minutes, thank you. Maybe there are other possibilities, and they've got some ideas. Maybe they want to have a go at making an SFU or an MCU. And actually, one of the things that I'm currently working on is implementing membrane framework into this, which is a bit like GStreamer, but written in Elixir, so that you could potentially stream recorded videos to an end user. And this is not a complete turn server in the way of being production ready, although it could be. It actually, let me show you, runs, oh no, wrong screen. Quick. Okay. There we go. So it actually, this is testing it with test.webrtc.org. First of all, with the Google turn servers, and then with Extern, and that's on a $5 VM. So it ran faster than Google's turn servers, and you know it's just this little thing running in Elixir. So it does have the potential to be something a lot bigger, but I'm not doing it, so I'm hoping one of you guys will. But yeah, anyway, that's it. That's it from me. Thank you very much.
Okay. Thank you, Jahred, for your talk.
You're welcome.
Got 2 seconds for any questions for anybody before.
It's not really a question.
Okay.
If you don't like the new WebRTC internals, Fippo also has WebRTC dump importer. And I find it much, much nicer. Because he takes all of the key bits and only gives you all of the information you actually need.
Okay.
So there's another tool. So WebRTC Externals is from Fippo.
Yes.
Then he also made WebRTC dump importer so that you can essentially do everything without the Chrome stuff.
What? I did not know that.
So that's really, really cool. And if you think reading RFCs is really simple,
Yeah.
I can't think of anything worse. I will be emailing you whenever I have an RFC question now. Thank you very much.
So long as it's an RFC I've already read, that's fine.
Sorry, it's really not a question.
Any other questions? I have to say, having written RFCs, they're all written by teams, so they're all mutually exclusive paragraphs. Makes it hard.
So, 2 turns and 1 load balancer.
Right. Okay. All right. Well, see, now 2-turn servers is interesting because you know, if you've got a guy in San Francisco and you've got another guy in Singapore, and you know, you want them to connect at the best possible speed, then it's ideal to have what they call, I think it's a trapezium model, where you have a turn server for each, and then they connect. That's certainly possible. That's not the vanilla turn capabilities, but there's no reason why you could not implement that, especially in something like Elixir, which is built for telecommunications applications. That's certainly doable. If you've got a fat pipe between them as well, then fantastic.
I have to read RFC to implement the thing.
Okay, last question.
So I'm curious, are we finally past the browser wars when it comes to WebRTC? Or
Past the what, sorry?
past the browser wars?
No, see, now, I was anticipating people asking me questions about the client API. I've not had anything browser-specific, anything related to anything browser-specific in about 3 years, because I like to prioritize the server-side stuff. But I know that they've been changing an awful lot, and there are issues with any one of them, and we're still not at WebRTC 1.0 properly, etc. But you know, I try and not have anything to do with that where possible. The differences, at least.
Can I jump in
Sure.
on that? Yes and no. If you really want to write something, you're still going to have to use the library from Google. It's actually not under Google anymore. It's under WebRTC Hacks. It's separate. You still have to use it. I tried 6 months ago to build a very, very, very simple WebRTC demo without it, thinking, sure, we're like 7 years in, don't need this anymore. And I failed miserably, and then half an hour later I put in the library and everything worked. So we're not past, we are past browser wars because no one's fighting anymore. We're not actually at a point where WebRTC APIs are where they should be.
I think if history's told us anything now, it's probably there will always be differences, and people will always be having issues with at least 1 or 2 at any one time.
Alex was like, do you want me to give a standard answer? And I was like, no,
Oh, no. All right, no.
So I think Dan put it well. Everybody agree around the table what needs to be done. The reason why adapter.js was put outside is because at this stage it's reducing in size because people are converging. So instead of having more things made different between the browsers, they eventually do the same thing. Chrome came to unified plan, everybody's happy. So the last bit that is a little bit problematic is simulcast, but more for quality and bandwidth management than anything else. So as far as WebRTC 1.0, the API, the codec and everything, everybody agrees and is converging, and the fact that adapter.js has been put outside is one visible symptom of that convergence. Even Safari adopted VP8.
Thank you, Dr. Alice.
Thanks.
So that finishes this session. We've got a little bit under 10 minutes of break before we have a fantastical demo, which we know nothing about except Dan will tell us about it in 10 minutes. So you're all on break.